10th, today we'll learn how to derive the formula for the volume and curved surface area of the frustum. First, have a look what is the frustum. Here in this diagram, you can see a big cone. If you cut off this cone by plane face that is parallel to its base, we get two things as shown on the left hand side. The upper part will be a cone and the lower part will be a frustum. So this is the frustum for which we will calculate the volume and curved surface area. Okay. For this, we have used some variables. As you can see, capital L will represent the slant height of the big cone. Small l will represent the slant height of the frustum. Similarly, capital H will represent the vertical height of the cone, big cone. Small h will represent the vertical height of the frustum. Now, if you subtract small l from capital L, we will get the slant height of the upper cone. Similarly, if you subtract small h from capital H, we will get the vertical height of the upper cone. And as you can see, the radius of the upper cone is represented by small r. Similarly, the radius of the lowest base of the big cone is represented by capital R. Okay, so capital R is representing the radius of the lower base of the frustum as well. Okay, or big cone. So be careful. Now, using these values, we will calculate the volume and surface area of the frustum. Let's move forward. As you can see in this diagram, if you imagine this diagram as a 2D diagram, you can imagine that VO complement B complement is a right angle triangle of the upper cone. Similarly, VOB is a right angle triangle of the big cone. This is also right angle triangle. So these two are similar triangles. How? Let's see. Have a look. Below this, I have drawn the two diagrams separately so that I can clearly show you the two things that are similar. Now in both the triangle, we can see that angle V and angle V both are common angle. Okay, so O complement and O both are right angle, so they are also equal. So by AA similarity, these two triangles are similar. We can say that they are similar triangles. Okay. Now, as already mentioned, that if you cut off this cone, big cone, into two halves, the upper part is a cone and the lower part is a frustum. So from this we can derive that if you subtract the volume of this upper cone from this big cone, we can find the volume of the frustum. Okay. By using the same logic, we can also derive the curved surface area of this frustum. Now, let's start. Triangle VO complement B is similar to triangle VOB. This means ratio of their corresponding sides will be equal. Okay, this means VO complement by VO will be equal to O complement B by OB is equal to VB by V complement B, V capital B. Okay. Next, now we will put the their values. The value of VO complement is H minus H by A. So H minus H by H will be equal to radius of the upper cone by radius of the big cone is equal to slant height L minus L by L. Okay, so I put their respective value in their proper place. Now, so VB is equal to V capital B is equal to L and VB small b L minus L. Okay, I put their values. Now, this means H minus H by H is equal to R by R. Okay, next, H is dividing here on the left hand side. H is dividing H, both the H, capital H as well as the small h. So we will separate these two. Now, H by H minus H by H is equal to R by R. On the next line, we'll see H divided by H is equal to 1 minus H by capital H equal to R by capital R. ठीक है. Next, this is equal to, by shifting minus H by R on the right hand side, we will get R by R, it will become positive H by H. Next, one minus R by R equal to H by H. Next, R minus R by R, by taking the LCM and adding this 2, we get this. This is equal to again H by H. By cross multiplying, we get H R minus R is equal to HR. Next, we get the value of capital H equal to HR by R minus R. So this is the first result we get. Similarly, by following the same rule, similarly R by R is equal to L by minus L by capital L. So ratio of OB by OB is equal to VB by VB. Okay, as I have written in previously, these are equal here, as you can see, this one. Okay, now continue with the same process. R by capital R is equal to, L will divide both the L's above, so we'll separate it, L divided by L minus small l divided by capital L. Okay, next line, this means R by R is equal to, L divided by L is 1 minus small l by capital L. Okay, next line, R by R plus L by capital L is equal to 1. Okay, next, this means L by L is equal to 1 minus R by capital R. Okay, by now taking the LCM, we get this. L by L equal to R minus R by R. Next line, now by cross multiplying, we get this, L multiply with R minus R is equal to LR. Last line, this means L is equal to LR by R minus R. This is the second result we get. Okay, now move to next line, where, as we have seen, let's see, for finding the volume of the first term, okay, we have to subtract the volume of the upper cone from the bigger cone. ठीक है? Okay, let's do it. Volume of first term is equal to volume of big cone. I have named it V capital A capital B. Okay, minus volume of small cone. VAB. Next, now volume of the cone VAB is equal to 1/3 of pi r square h. Now volume of small cone is equal to 1/3 of pi r square capital H minus small h. Okay, next line. By taking 1/3 pi as common, we'll get, and writing the remaining terms within the bracket, we'll get this r square h minus r square h, capital H minus small h, bracket close. Next line. Pi मतलब 1 is pi by 3. So next, now we have to write the value of h from first equation as we have derived. First equation says that value of h is equal to h multiplied by capital R by R minus R. Next, minus, so we replace h with this, capital H with this. Okay, value of h is hr by R minus R minus h, bracket close. Next line. Pi by 3, r square r is r raised to power 3 h by R minus R minus r square. Now we will subtract these terms. LCM will be r minus R, multiple 1 is r minus R. Now, so by cross multiplying we will get the above terms. HR multiply 1, cross multiplying means this way we will multiply, cross multiply. So HR multiply 1 is HR minus, then H multiply by R minus R. So in this way you will solve it. This will the curly bracket. Next line. Pi by 3 r cube h by R minus R minus R square, curly bracket, h r minus h multiply r is hr, h multiply r is plus hr by R minus R. Now next line. HR or minus HR is 0, so no need to write again. Pi by 3 r cube h by R minus R minus R square multiplied by HR by R minus R. Next line. It will be equal to pi by 3 r cube h by R minus R minus R square multiplied by R is r cube h again by R minus R. Next line. Pi by 3. Now again, by taking LCM, LCM will be same, R minus R. Okay. Minus R cube h. Now by taking common, we'll take the common term out of the bracket. So pi by 3 common term is multiplied by r cube, h is common in both the above term, and R minus R is already common, so it will be taken outside, and then the remaining term will be keep it inside the bracket. Next line. Pi by 3 multiply with h by R minus R, or AQ minus BQ formula is there. AQ minus BQ is equal to A minus B multiplied by A square plus A into B plus B square. Okay. So I have expanded this formula into this. AQ minus BQ is equal to A minus B, A square plus AB plus B square. Okay. Now next line, it will get cancelled out. This one cancel out, and the rest of the remainder I will write down pi by 3 h multiplied by r square plus r into r plus r square, small r square. So this is the formula for the volume of the frustum. Okay, now we will derive the formula for the curved surface area. Curved surface area of frustum is equal to curved surface area of big cone VAB minus curved surface area of small cone VAB. Okay, next line we'll write. Now the formula is equal to, the curved surface area of cone is formula is pi RL. Okay, it is pi capital R and capital L. Okay, of the big cone minus volume curved surface. The formula of curved surface is pi small r, L is here, L minus L. I have already discussed about this in the diagram. So curved surface of the small cone is L minus L is the slant height and radius is smaller r. So pi r L is the, this is the curved surface area for the smaller cone. Now we'll take pi as common and r L minus r multiplied by L minus L. In the next line we'll put the values of L from the second equation. Pi. Second equation says that, as I have already discussed, value of capital L is equal to LR by R minus R. Okay, minus R. Replacing the value of capital L with LR by IL, R minus R minus L. Next line. Pi R multiplied R is R square L by R minus R minus R. Now by taking LCM, we'll take the LCM out here again. So R minus R is the LCM again. So LR will come as it is, LR minus, and L will get multiplied with R minus R as discussed above. This is the same equation. In the next line, pi R square L by R minus R minus R LR minus L multiplied R is LR again, minus L minus R is plus LR by R minus R. Next, LR minus LR is 0, no need to write again. Pi by R square L by R minus R minus R. LR would get cancel out. Okay, so it will become LR by R minus R. In the next line, we will multiply pi by R square L by R minus R multiplied by next minus R square by L, R square L by R minus R. Next line, we'll take the LCM and add these terms, pi, or we'll take out the common terms. You can take out the common terms, that is L by R minus R is the common on both the terms. We'll take it out and write the next remaining terms inside the bracket, that's R square minus R square. So in this way we'll take we can save some time, no problem. So L by R minus R, this is the common term of both these terms, so we can take out. Okay, now we'll write the next line, pi multiplied by L by R minus R. Now R square minus R square is equal to, formula is there, A square minus B square is equal to A plus B, A minus B. So here you will apply the formula A square minus B square. Okay, so we will get A plus B multiplied by A minus B. So this will get cancelled out, this entire thing will get cancelled out, and I will write rest of the remaining things, pi multiplied by L multiplied by R plus R. This is the formula for the curved surface area of the frustum. Okay, and this is the end